I have no mic.
Search for like swear words and shit. Just laugh at the instances of like, words in the big scroll. I also use it for like non-free. What's that? I'm actually using code search to search for non-free clauses and licenses.
Good? Should I start? So hi everyone. Don't worry, there will be no free software politics in this talk. With that, I'm done with the opening talk. This will be a pretty standard technical talk on a tool and a piece of the Debian infrastructure I've been working on, which is called Debsources for the software that implements it, and which has its main instance at sources.d.n. So if you've never used it, or if you want to check the stuff I'm saying live during the talk, I encourage you to just go to sources.d.n and see the stuff I'm talking about. So in this talk, I will just give you an overview of why I've created Debsources and why it exists. A little bit of feature, so kind of a cheat sheet of how to use it. Some technical details for the people that might be interested in hacking and helping me maintaining the tool, and a roadmap of the stuff that is upcoming with it. So with the overview, in a nutshell, Debsources is essentially a web app that allows you to browse all Debian source code via the web. So essentially it's a source code highlighter in which you can pinpoint every single file contained in a Debian package and see what's in it. Okay? So the main instance is here. The idea is pretty simple, but it seems to be very useful. Okay? I think it's useful for us, Debian people, to just like when you chat about specific bugs and specific lines of a source code file in a package, it's nice to just have a URL you can point to when discussing it. And it's easier than saying, yeah, you need to just download this package, open this file, and so on and so forth. And I think it's also useful for the broader free software ecosystem to be able to check what's actually being built in Debian. So what's in there? What are the Debian people doing? It poses some system-level challenge to get it right, because it's a fairly big amount of data. I'll enter into that in a minute. And in my opinion, is possibly the highest abstraction layer at which we can show the source code contained in Debian. Because if you use something else that we have a developer use to develop packages, for instance, if you look into version control system, it's fairly difficult to find out a common workflow or even a common branch structure, right? It's something that we've been discussing the very same days on Debian Develop. So it's fairly difficult to offer a common view over different source packages, okay? So I think this is the best we can do right now to expose the Debian source code to people around the world. Before going further, just a few acknowledgements. So I need to thank my employer, Iril, that essentially has sponsored the initial development of the web UI that's been done as an internship by Matteo Canai, and is also sponsoring the hardware and the hosting for the current infrastructure, and is also quite happy in having me working on this in my famous spare time. There are other contributors that you will find in the contributor file, and I hope that by the end of this talk you will be interested in adding your name to the list, to this list of contributors. So, research motivation, that was the initial reason why I developed Debsources. Essentially what we wanted to do is try to do some static analysis on all the packages contained in the Debian archive. So we wanted to see what happens, what are the trends in bugs that can be found by static analysis tool, okay? And now how we can analyze those. So there are some tools that we are developing ourselves, like Coccinelle, that you might have heard of. It's essentially a sort of grep and sed that understand the semantics of the C language and can be used to establish bugs pattern and actually even generate automatically patches for specific bugs. It's being used by the Linux kernel, and it's very cool stuff. There are other tools like ScanBuild by the LLVM toolchain, and there are a lot of static analysis tools you can run on a huge load of available source code. It should be something that keep up with Debian uploads, so as soon as there is a new upload, you want to rerun all the checks. It should be integrated well in all the Debian infrastructure, and ideally, it should have some layer of community review. So you know, when you run static analysis tool, you will find plenty of false positives, false negatives, and before submitting bugs automatically to people that maintain its software, you should really do that because they won't be happy about the false positive. And essentially what you want to do is essentially have a community of people that goes through the issues and says, this one looks like a real issue, let's submit it. And no, this is not a real issue, so let's ignore it and do something to avoid it keeps on popping up in the future. So this was our initial motivation. And to do that, what we wanted to do is not to implement a thing that would do all of this, okay, but actually have some sort of Unix-like architecture with small parts that do a single thing and do it well. So what we wanted to have is a network, essentially a rebuild or a static analyzed network that will keep up with Debian uploads, a web apps to browse the results, okay, and a web apps to browse specific source code and pointing to the lines which are affected by the issues. So what we ended up having is actually Debsources is just the last part of all this. So it's essentially only the code source browser with the ability to add specific messages to specific line. And then there are other stuff. This one developed by the Matteo as an internship, which is essentially a web app to show the result of static analysis tools based on a format called firewalls. And then there is the build, which has been developed by Paul and other people to actually do the real network that keep up with the builds. I guess I'm at fault for all the three names, so if you don't like them, feel free to blame me. But it is a kind of architecture that we have ended up having. So the Debsources is just the last part. So what you can do with Debsources, so this is the main instance you might have used already, okay? It's essentially offering you various ways to navigate through all the source code which is there. So feel free to play with it during this talk. The main thing you have is essentially package browsing. So you have the package browsing by letter prefix. You have the usual stuff. When you have ended up selecting a source package, so the name by default are all source packages. So if you're looking for a binary package and you don't find it, that's normal. You need to use the source package name or alternatively submit a patch for doing automatically the redirection. Okay? When you've found the source package you're interested in, you choose a version among all the versions available and look what's in. When you arrive at a specific version of a package, what you find is essentially the content of the source package as obtained with dpkg source-x. So that means there is some lack of uniformity there. For instance, patches might be applied or not, depending on the patch system you're using. And with recent packages that uses the 3.0 format, so DPKG source format, what we will end up having is a set of a source package with patches already applied. If you're looking at kind of old packages or other packages that apply patches at build time, you will find patches which are not applied. So this is a kind of uniformity that was difficult to get around, so it's exposed to you as it is. What you have is some HTML syntax highlighting, so depending on the source file you are looking at, it will recognize the language and will try to do some syntax highlighting in your browser. So it's client-side, everything is delivered to your browser, and there is a JavaScript toolkit which will do the syntax highlighting in your browser. There is some file type detection based on both the extension of the file and the shebang lines, if it exists, meaning that we will recognize Perl files even if the name of the file is not .pl. And this is thanks to the Guinea people. Guinea is an IDE with which they've shared with us their rules. We have adopted it, and they just work, for the most part, very well. What you can do other than that, we have various kinds of searches. You have package name searches with some substring matching, which is pretty cool if you don't remember the exact package name. We have all the SHA-256 of all the source code files we index. So if you know the checksum of some file and want to look it up, you can do that. And this is also used to talk about duplicate detection. So whenever you are on a single file within Debsources, it will tell you the number of duplicates that exist for that file in the code base of Debsources itself. And finally, we run C tags on every file we have in the database. So essentially, you can do searches like, tell me which file contains the function printf. That would be a very bad query because you will end up having a lot of files containing, well, no, printf, not that many, but print, you will find many, many files defining a function called print. So we'll end up having a lot of packages. So this is the kind of searches we have integrated in-house. And then there is a very cool integration with a service which is not provided by us, which is called Code Search Debian Net, which is maintained by Michael Stapleberg. And essentially what it's doing is full text searching of source code. So it does some full text indexing of huge amounts of source code, and it allows you to search for it. It's the tool we have been using to find how many packages in Debian contain you must do no evil and file a number of RC bugs, right? So there is a kind of a quirk here because Debian Code Search itself is not capable of indexing all the source code we have in Debsources. So it's only indexing unstable, essentially, and it's updated, I think, once per week. So there is no guarantee that everything which is in Debsources will be found using Debian Code Search, but it's kind of cool. And the integration is nice as well. So essentially, you have a search form for source code on sources Debian Net, which will use Code Search Debian Net to do the search. And the result you will get from Code Search Debian Net will point back to Debsources to show you the results in the usual interface. Given that Debsources was meant to be used in collaboration with other tools, there is some sort of API to work with others. So a first kind of API is a URL mechanism which is granted to be predictable. So essentially the URL here will be always produced this way, so you can point to a specific file in a specific version of a specific package, and this is the URL scheme that we were using now. You can point to a specific line with the sharp L37. You can highlight line ranges. So you can add stuff here, and it will point to a specific line and add some kind of highlighting to individual lines if you want to talk about them. And you can add pop-up messages. So essentially you can pass a parameter here saying message 22 cow say blah blah blah, and it will add a pop-up messages in your browser at the specific line. Okay, this is what we mean to use for errors. So there is a static analysis tool that will return some specific errors associated to a line, and the idea is that to point into Debsources, they will use something like this. Okay, and there is also a specific URL for iframe embedding. So if you are developing another web application in which you want to have some specific source code highlighting of some code which is in Debian, well, there is an URL which I'm not showing here, not sure why, but in which you can just know that using that URL will give you the content of an iframe you can embed in your application. Everything is documented here, so I won't go into more detail. There is a JSON API, so essentially everything you can do as a user while browsing, you can do also with a JSON API, so you can check which versions of a package are available and retrieve the source code of the file and so on and so forth. So if you need to integrate that in something which is not a web thingy, you can use the JSON API to do the same. This too is documented at the URL which is on this slide. In terms of coverage, essentially we have two parts. We have a live archive, so a part which is keeping up with what is live in Debian, meaning stuff which is shipped by the usual Miro network. And what we cover right now is essentially everything on the official network, Miro network. Okay? That means you have everything from old stable to experimental. Given that in the last few years we have migrated some stuff in and out the main archive, there are some weird glitches. For instance, with the backports is in, because it's the first version of the backports archive which is shipped by the main Miro network. But squeeze backports is not there because it was on a separate archive. So still, we have a single Miro network for now, so you will not find security in there, and you will not find any derivative. This is something on the roadmap to be fixed. There is garbage collection, so we cannot afford for now, but might change soon, to keep all versions of all packages that ever existed in Debian, so we are not as complete as snapshot Debian could be. And what happens is that when a package expires, meaning when a package disappears from the Debian mirror, we wait for 14 days to avoid creating stale URLs immediately, and then we remove it from sources Debian.net. Okay? So the URL which I've shown before are not granted to be stable, are not granted to exist forever. And when some packages appear from an archive, at some point it will disappear from sources Debian.net as well. Hopefully this delay will allow you to catch up with the kind of indexing you're doing yourself of the Debian archive. The updates are push, so they're coming from a tier 1 Debian Miro. That means that the lag is minimized. So as soon as there is an push to an update in the Debian archive, it will inform Debsources. Usual update runs takes about 30 minutes. Okay, these are the good ones. The bad ones, when we have to index the Linux kernel, Chromium, LibreOffice, and blah, 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 can take up to a few hours. Okay, so usually we are well able to complete before the next push run. So that was for the live archive. Then there is the historical archive. So what I've done, I think last summer, or maybe it was I think it was last summer, was to actually work on injecting all the historical releases of the Debian archive. So I went to archive.debian.org, that in case you're not familiar with, is a kind of mirror that keeps all the old Debian releases which are no longer on the Debian mirror, and injected all of them in Debsources. So that's a kind of toy for the statistic geek. So if people want to do stuff like monitoring what is the most popular programming language in Debian since the end of the 90s up to today, you can do those kind of investigations. So for instance, I'm not sure what I'm showing here. So this is the number of SLOC of C, C++, Java, XML, Shell, and Python, which are the top languages over time. And here you should see how they evolve. More interestingly, is the relative distribution of languages in Debian over time. So here you see that in the beginning we had C, which was 70% of the archive. Then it declined, and then it might be going up again now. The language which is here is actually C++, which kept on increasing, and you don't see much here because maybe I should have used some log scale. But all this data is available. Okay, you can check for it on the website under stats, and it's kind of funny to play with. Adoption. So given the original motivation for me to do that was some kind of research purpose, I'm happy to say that it's been starting to be adopted in the research world. So with Mathieu, we've published a paper in a quite important conference about software engineering and measurement. And the idea is that we are selling both Debsources, the software, and the dataset which we obtained with it as a kind of toolkit for people interested in looking at the software evolution of free software over long periods of time, and to extract and do everything they would want with the extracted data. We've also been able to essentially replicate and redo one of the major studies in the area using this dataset, essentially confirming most of my results and finding some quirks in what they did at the time. The paper is available on my own page in case you're interested in looking at it. Adoption in Debian, well, I've already talked about the integration with code search, and I was really happy about that. It's been already integrated in the PTS, thanks to Paul Wise, and essentially you might have noticed that associated to any single package in the PTS, you now have a browse source code link, which will bring you to browsing the source code of that package, and also a search source code form in which you can search within that package. So if you want to find a specific snippet of code in a specific package from the PTS, you have a way to directly do that. Of course, if you want to integrate other Debian services with it, you're more than welcome to come and talk to me. I'd be happy to help you doing that. Adoption in general, so the reception seemed to have been quite good. So LWN talked about that. There's been some blog posts on the official Debian blog, and was really happy about that. It's kind of increasing, so we are at about 3,000 requests per day. It's slowly increasing. And my feeling is that people were generally quite annoying of having to do apt-get source or maybe deb checkout before being able to look at a single line of code in a specific Debian package. So even the idea is essentially straightforward, this service is essentially filling something we were missing in our infrastructure for since quite a while. So technical details for people who might be interested in contributing. So this is the architecture. I had to do that for the paper we submitted, so that's why I spent some time in making such a big picture. So essentially, as a backend here, we use the Debian Mirror network and archive Debian.org. We mirror it locally in different ways, because you can mirror the main archive using DebMirror, but you cannot mirror the historical archive using DebMirror, given the archive format evolved over time. So this is plain old rsync. So locally, we have a big local mirror. Essentially, we have two kinds of triggers that will trigger an update run. So it's either cron, if you have not connected your Debsources instance to the Debian mirror, or if you have done that, well, you will essentially have the mirror itself, which triggers an update. Okay? The Debsources updater then goes on. Essentially, what it does first, it will update the mirrors. It will extract the package and metadata from them, filling a database. Okay? And then what it will do, it will run several plugins that are in charge of doing all sorts of indexing on the source code which has just been extracted. And on top of this, we have several interfaces. The main one we have seen is the Debsources web application, which you can peruse via HTML or JavaScript. And in addition to that, you have a various kind of API. Of course, we have the JSON API I've talked to you about. And in theory, we can also open up SQL queries. Right now, they are not open up to the public because it's too easy with SQL to actually DOS the system. But if you're interested in doing specific queries over time, I can give you access to you and we can work something out. We have various plugins. So this is an excerpt of the database schema. Here you can see some numbers if you are a geek for that stuff. We have 16 Debian releases over time. We have about 30,000 package names, 83,000 source packages, which means 83,000 versions of source packages over time. And these are the plugins that we run. So on every single package that is extracted, we run disk usage, which is essentially a hello world plugin to show how to create a plugin. We run slot count, to count the amount of lines of code for every single language in the package. We run checksums. This is the plugin that checks the SHA-256 of every single source code file. And we run ctags. This is the number of rows we have. So the biggest table we have, the ctags one, with about 360 million of rows. So for database geeks, that might not be that big. So I've spoken with the Postgres maintainer in Debian. This is the kind of database they use for testing. But for me, that was a pretty substantial database. Disk usage, in case you wonder how much it takes to use this, to host this kind of infrastructure. Right now, we have 6 gigs of unpacked source. There is no deduplication on this. I will come to that in a minute. The Postgres DB is 100 gigs. I think more than half of it is actually indexes to make queries feasible. So I think the real data here is about 40 gigs. The source mirror, in the end, is the smallest thing we have. It's 70 gigs. And in total, we are well under terabyte of data. So that's not that big for today requirements for hosting a significant service. This is the evolution of disk usage over time. And the peak here is when I've injected all the historical releases. This is not 0. This started 3.5, so it's not like we went 10 times up when I injected all the historical releases. In case you want to have a look at the code, so the kind of technology we use is pretty straightforward. So we use DebMirror for the mirroring part. The DB is Postgres, 9.1 or plus is required. I don't remember why, but it works on a stable machine. Python is the implementation language of choice. And the main technology used on top of Python for the infrastructure part is SQL Alchemy. So there we have nice models you can use to query the database, and it's working pretty well for us. At every update run, what will happen is that, well, I've already went through that, and essentially, after updating the source mirror, we unpack all the new packages. We do garbage collection for all the packages that have disappeared, and we updating the stats, which essentially means running all the plugins. Possibly the most tricky part is that we run fairly large and nested SQL Alchemy transaction, which surprisingly works pretty well. So this is the most difficult logic code you will find are those kind of nested transactions, which are hidden for you, so there is no explicit begin transaction, but the SQL Alchemy code could become a bit tricky. The web app is straightforward as well. It's Python Flask as a toolkit. And the other big component we use is highlight.js to do the syntax highlighting on the browser of the user. So we do not use automatic language detection by highlight.js, which is supposed to be one of the major features of the tool, because essentially highlight.js was meant to actually include code snippets in blog posts. So essentially the parts in which you have to do the automatic detection is fairly small, and it was working pretty well. But it turns out that when you show entire source code files on the web, the automatic language detection will not work that well. So what we do, we use the Guinea convention, which I've mentioned before. If you lack source code highlighting for your favorite language, the first thing to do is to go and add support for it to highlight.js. So I've been asking in the past to do that for specific languages, like the Scilab language, or I don't remember what else it was. But that's the place where you need to add your support in order to have sources.d.n using it. What else? Roadmap. There is a bugs file. I still have to migrate all the bugs to the qa.debian.org website. I plan to do that during DebConf. So there are some low-hanging fruits, which are the parts you might want to start looking at in case you want to contribute. So one is that we have made all sorts of fancy stats for the paper we have published using matplotlib, but essentially they are not live. So we have produced it for the paper, but they are not shown on the web interface. So it would be nice to essentially have all the same kind of stats we did being live and updated every time we do something, every time there is an update. It would be nice to have some file name search. That's not implemented yet, but it's straightforward because we already have the table with all the file names. And there is some interesting Postgres thing to be done here. There are some specific indexes which work well on file names. So if you are a Postgres geek, it might be something interesting for you to play with. As I mentioned before, we do not have yet any kind of redirection from binary package to source packages. That would be nice to have because many other services in Debian have that. So essentially, we still lack the injection of binary package names in database, but the database structure already supports that. So again, this should be a fairly easy hack. We do not support tarball in tarball. So you know those horrible Debian packages in which you do dpkg source extraction, and then everything you find is a Debian directory and a targz. Okay, that's fairly annoying to deal with. To some extent, I really don't want to add support for that, because if I can add another incentive to make tarball in tarball packages die, I'm happy to do that. But to some other extent, given we have all the historical releases, it would be nice to look to, to be able to point to a source code file in bash, for instance. That would be kind of nice. So that's not too difficult to add, but it requires some work. We have a test suite. which is a quite interesting thing to do in this case, because wrapping all the real work which is happening in some virtual environment to do the testing could be challenging. And we do not have 100% test suite, so if you are a testing geek which likes doing this kind of stuff in Python, well, you're welcome to give a hand. Something more substantial, we do need multi-archive support, mainly for security, because it's really annoying not to be able to really see the kind of software we are shipping to users in case we have released some security updates. So that would be interesting to have. And file-level deduplication. So essentially, I was curious about how much disk space we could save if we actually do deduplication at the file level, right? So right now, there is no deduplication at all. So different versions of the same package will occupy essentially twice the space. But in most cases, a subsequent version of a package will share a lot of files with the previous one. So given we have the checksum, we already have the information about this. This is through the old historical archive. So I think you might expect it to be higher, I guess, but this is what we get. So if we do the deduplication right now, we will essentially halve the space required to host, beware, only the unpackaged source parts. Okay?
And you can index snapshot.
Yes, I think so. I think so. And even more interestingly, so I think Pubs is not here, but Pubs has proposed to actually inject derivatives in sources.d.n. So taking Ubuntu and putting it into sources.d.n, taking all the other derivatives we have in the derivative census and injecting to that. I think that would be feasible because the amount of overlap that derivatives have with Debian is very, very high. I mean, Ubuntu is probably the one that has drifted the most, and I think it has 10% or 15% of packages which are really different. The other one are pretty much based on the Debian ones. So, Tom.
I wonder if it would be possible. Would it be possible to do diffs and show diff syntax highlighting diffs of the differences between different versions?
Yes, so this is a feature that we have on the to-do list, but the point is that what we can easily do is diff on demands, right? So having an interface in which you choose a version of a package, and you ask, show me the dep diff among these two versions. That is feasible. What I think is not feasible is pre-computing all the diffs because you have all the pairs and that explodes fairly soon. Yes, that's something that we want to do. So that's absolutely feasible. But regarding derivatives, they are already doing diffs with respect to Debian. So I think if you look into the derivative census, I think they are already doing periodically diffs and keeping an index of all diffs between Debian and derivatives. So that exists already, but it's a feature that would be nice to have here as well. And another kind of crazy idea, which I like quite a lot, I don't know if you have ever seen the Linux cross-reference. It's essentially a website that lets you browse through the kernel source code and essentially hyperlink each function definition, each function usage to the function definition. So imagine being able to do this kind of thing across all of the Debian archive, so that when you have a package using a library, you browse the source code of that package, it's calling into another library, you click on the function name, and you end up on the other package where you have the definition of the function. That would be very cool. It's not that easy because as long as it's a single project, a Linux kernel, even if it's big, you have not that much ambiguity. While if you do this here, you will have a lot of symbols that have nothing to do with your package that might be its own definition. So there are some strategy you can use to do deduplication, for instance, looking at the dependency of the package or ensuring it's the same language and so on and so forth. But it would be a fun exercise to do. So if you're interested, and if I manage to get your attention on this project, we try to follow the best practices in Debian to advertise development information. So every single service in Debian which has a web interface, in my opinion, should have a footer pointing you to the source code of the service, pointing you to where to report bugs, and pointing you to how to contact the maintainer of this service. So just look at the footer of sources.d.n and you will find all development information. You will find the pointer to the Git repo containing the code, which, by the way, is a FAO-GPL licensed. So the source code should always be available no matter who is deploying the system. You will find a pointer to the list of bugs. You will find, then there is an about page with more information. And the place to discuss this in terms of development is the Debian QA list. So just show up there. Or the Debian QA IRC channel. Feel free to highlight me. I'm Zach, the ACK on the channel, if you have a specific question about Debsources. So to summarize, Debsources seems to be a very simple idea, yet very useful. And there are quite a bit of fun development tasks in case you want to participate. Thanks.
So we have a derivative, and one of the things that we have to do is pull all the sources, do analysis, and find out what all the licenses are associated with the pieces so that we know what the legal ramifications of that. So is there a vehicle or mechanism in your analysis and filter to perhaps hide all the licenses or create an index for licenses?
Okay, so in the service offered on the web, not yet. What I'm working on, because it's a topic I'm very much interested in, is using the same set of data to expose on the web and with some kind of API the content of the Debian copyright file, as long as those files are machine parsable. So you might be aware that we have two different formats for Debian copyright. The historical one, which is not machine parsable, so you can do some sort of heuristic on top of it, but not much more than that. Or we have a new format, which is the machine parsable Debian copyright format. And they've been monitoring the usage of that format using this corpus, and it's now about 60%. So if you look at unstable, about 60% of the licensing information that Debian provides are encoded in that machine parsable format. So what I wanted to add on top of this is a service in which you will tell the name of the package, the version of the package, and essentially will get back to you the information contained in Debian copyright. Okay? So if you want to do the analysis yourself, maybe because you have a derivative with other information, there are essentially two possibilities. Either we make it true, we make it real, the idea of injecting derivatives here, and then you will get the service for free, or you can deploy yourself Debsources and use the machinery I'm going to write.
That was the second part of my question was, is this something we could set up and do a copy ourselves, or is it fairly complex, obviously?
No, it's, so the source code of that platform itself is available. You can deploy it wherever you want. I'm not aware yet of other deployments, but I've documented how to do that, and I've been in touch with a couple of people interested in deploying it for their own internal distro or whatever, so it's absolutely feasible. And in the paper, I've also documented the full process you will need in case you want to re-inject all the data that I have here. Probably you are not interested in the historical data of Debian, but maybe you have some historical data for your own.
Actually, there is quite a bit of interest in the historical, and would probably utilize your instance in that space because code volatility, bug volatility, all of those things are important in understanding, the stability of an overall package that comes from the sources.
Okay, great. So it seems like there is some margin for collaboration here.
Yeah,
thanks.
Good.
Michael?
Yeah, so you noticed, or you mentioned that there's a problem with the source and binary packages. So I guess that information is in DAC, right? And Don also mentioned it in the bugs talk. So I wondered, newer versions of Postgres can query remote tables as if they were local. Did you talk to people that you could just use the DAC table in that sense? I don't know whether it's a performance problem, but maybe that might be a solution and not everybody redoing the whole thing all the time.
So I agree. So as maintainer of the main instance, I would be skeptical in adding, a runtime dependency to another service. But as maintainer of the code base, yes, I would love to not having to redo all the injection myself. So what I think would be very cool is to agree on some sort of model for SQL Alchemy or whatever for a subset of the package information and have code that injects that information from the packages and inject into the database. At least everyone will not be redoing the code to do the injection. Maybe Paul has some comment about that. Okay, we'll talk. Paul's comment is we will talk. One just behind you.
A few years ago, I was working on a legacy. A few years ago, I was working on a legacy project, and I needed to be able to build something that required specific versions of libraries, and I ended up installing Woody. Oh my God! I was like, it was already like 10 years old at that point, and so I can see some usefulness in historical stuff so that I could find, it's like, okay, which version of things can I
Right.
find, where can I find this version of things? Because otherwise this stuff wouldn't even compile.
Yeah, so I agree. So that kind of use case, long-term preservation of free software is very dear to me. I don't think that Debsources should become the platform you get the code from, but it's absolutely reasonable to expect you use this to actually find out which version you need, and then you go direct to the source, right? So archive Debian.org, it's the proof that Debian project in general cares very much about not losing all releases. So maybe you could just use this to find a specific version, and then you go to archive.debian.org and you retrieve the version of the package you want. Maybe I could help making it easier associating to any single version of a package the origin for that specific package. So maybe I could provide direct pointer to the DSC that existed in archive.debian.org or something such. If that could help, let me know, and I could totally work on it.
Hopefully I only had to do this once ever in my life.
So far.
Felipe?
Hey, Zach. So following on Mika's suggestion is, there are a few things that you said you want to implement that will align with like packages and package QA stuff, like finding file names, finding binaries, and then also package also has like an entire dump of things. How are you planning on duplicating or integrating? Do you have anything looking out on those types of tracker package QA?
So regarding packages.debian.org, I didn't think about getting in touch with them, also because it seems to me the code base might be kind of old these days. So I wanted to do something, more maintainable, and more importantly, something that could be more appealing to, new contributors to contribute to. I don't know what we can share with them. With tracker.debian.org, that might be a different matter. Yeah. Anyone else? Okay, thanks a lot for your attention.